Algebra 2, Chapter 2.1, Exercises 1 through 13. This has to do with graphing absolute value functions. I'm going to do in this set the odd number problems 1, 3, 5, 7, 9, 11, and 13, but I encourage the viewer to work every problem out before I work it out, just to see how you do and verify how things are going. And for this set, since predict how the graph of g of x is a transformation of the graph of the parent function f of x equals absolute value of x, verify the prediction using graphing calculator. So this exercise presumes you have at your ready a graphing calculator you can have access to. There's one that you can get for your cell phone. I can show you in class. I mean, it's an Android one you could get. And I hope most of you do have your own TI-84 related series calculator to help with these. Problem 1, g of x equals 5 times absolute value of quantity x minus 3. So I hope that you remember that the basic, the standard form of the absolute value function is going to be this one. The f of x equals a times 1 over b times quantity x minus h, and then close absolute value brackets plus k. And so your vertex is going to be the coordinate pair h comma k. And in this case, you don't have a k for problem 1 because this is plus 0. You don't have a k to the right. And so in this case, h is equal to 3. So therefore, for this one, the vertex is going to be the coordinate pair 3, 0. And this a value here, this a value refers to the vertical stretch for compression. And in this case, we have a number greater than 1, so the thing's going to be vertically stretched by a factor of 5. And so let's go to the vertex here. We have the vertex 3, 0. I'm just going to arrow here to it and mark it right here. And we have the vertical stretch by a factor of 5. That means it's like a rise over run of 5 over 1. So it's like we go up 5, 1, 2, 3, 4, 5, over 1. And I'm going to erase this. It so happens that I'm so I'll go here and put up 5 over 1. And then likewise on the other side. So this is what we would expect to see on our verified in our calculator. And I hope you can see the logic in this. But the moment of truth is when we go look in our calculator. So let's do that. Okay, I have my window there. What I'm going to do is go to second format, and I'm going to go get a grid line to help us look better at the situation. One thing I want to do here, well, I want to keep the negative 9.9 and 9.9 here, and I'll tell you why later on, maybe. But anyway, we go to y equals, and we put in 5 times quantity, and we go to second catalog, enter, and we're going to have x minus 3, and we don't have a k on the outside, so when we use press graph, we should see what we get here. here's the graph here. We have our vertex at the point 3, comma 0, and then we are rising 5 and over 1. So that matches. These faint lines really help you kind of get a picture of what's going on. So that definitely checks out. So this would be a proper graph as drawn for problem number 1. I invite the viewer to look at problem number 2. I'm going to go on to problem number 3 in this video lesson. Okay, in this case, we have g of x equals 7/5 20x minus 6 plus 4. And one thing we can do in this instance, we could call this 7a and then call this over here 1 over b. Or we can put the 7/5 outside. For this type of function, it really doesn't matter. Let's find the vertex. Okay, we have h comma k is going to be our vertex, and that's going to be x minus h here plus k. Well, in this form, x minus h would have to be 6. So that's our x-coordinate. And then we have plus k, well, k is 4. And so that's what we have. And so we go 6 to the right, and we go up 4. So this is going to be our vertex. If I come here, just going to arrow over to the vertex. And we have a value here of on the outside 7/5. So that's going to be up 7 over 5. And I don't think I have a lot of room in the version of this graph here, but I'll just make the best of what we have. So it's going to be, these are going by 2 here. 2, 4, 6, and then another 1/2 of these will be 7 up, and then 5 to the right. So I'm going to go to the left, I have more room. 2, because these are going by 2, 2, 4, 5, so it's going to go right here. And the other side is going to go 2, 4, 5. So we're going to be looking at something like this. Let's see. Yeah, it looks like we're going to hit pretty much this corner here, 10, comma 10, if that's right. And then on the other side, we're going to be coming like this. So using the principle of rise over run really helps us sketch the graph of this. And let's go verify in our graphing calculator. So this 5 we're going to replace with alpha y equals, there we go. We're going to put, actually what we're going to do is we're going to put that on the inside, just like they did here. So I'm going to put Control INS, and then I'm going to put alpha y equals enter. So I'm going to put 7/5 right here. And then I'm going to open the parentheses here. Oops. Well, I'm going to have to go ahead and put second INS. X minus 6 here. And we come outside here, and we're going, is it plus 4? Yeah, plus 4. So plus 4, we'll just see what it looks like. See if it's the same we have here. So we have the 0.6 comma 4, and then we're going up 7 and then over to the right 5, which will be here, and we can just go ahead and change the window to make sure we have room here. I'm going to go up to 11. That'll give us all the room we need to hit here. Well, to the right also, we want to get up here, but we can see that we should hit the point 1, 11, right? Let's check this. So we get 1, 10, 11, that's about right. And the aspect is a little off because in the graphing calculator, we don't have this squared dimensionally off. We press zoom squared, we're going to see the shape better. See, that shape is more similar to the one we sketched here on the graph. Okay, next. Let's go. So we worked well on that one. Number 5, we have 7/5 absolute value quantity x minus 2 minus 3. And again, I invite the viewer to try to work this out first. Pause. Okay, I hope you've had a chance to work this out. In this instance, your coordinate pair h comma k is going to be equal to, we have x minus h, so h is going to be 2, and k is going to be -3. So let's go plot that here. We go 2 to the right and down 3. So there we have it. And then our a equals 7/4. So we're going to go 7 is going to be equal to our rise, and then 4 is going to be equal to our run. And we're going to have to do this on either side. So we're going to go up 7. So 1, 2, 3, 4, 5, 6, 7. And we'll go to the right 4. So 1, 2, 3, and we have to go off the grid here to 4. And the left, we have to go up 7 and 4 to the left. So up 7 to left, 1, 2, 3, 4. So this is what this one should look like. If I could draw straight, that'd be nice. There's a straighter. And we should go through the point here. It looks like 6, 4. And then on the left side, we should go through the point over here, which is -2, 4. 6, 4, -2, 4. Let's check it out. Okay. If I get the right one, that'd be great. Okay. Let's make sure we get it in the right place here. We're going to have 7/4 outside, x minus 2 minus 3. So we'll go alpha 7/4. We'll go x minus 2. And we can delete everything else out of here. So I'm going to delete that. X minus 2 into the right here. we'll put minus 3. And that should be it. Graph. So we should go to the point 6, 4. Let's see, 1, let's see, 3, 4, 5, 6, 4, and negative 2. Yeah, so that looks, and what you can do in these instances is you can go ahead and emulate the X and Y value on the graph, but that definitely is it. We've checked. So that's our graph right there. Okay, next odd number problem, 7. We have g of x equals 4/3 absolute value point x minus 5 plus 7. Well, here the coordinate pair h comma k is equal to 5 comma 7. Then we have 4/3. So let's go find that vertex. We have 5 comma 7. So each one of these tick marks here is 4. So 5 is going to be just to the right of this 4 tick, and 7 is going to be up here. So we're going to be right here for our vertex. And we have A is equal to 4/3, where we're going to go up 4 and over 3. So there's up 4 and over 3. These are 4 pieces, so we're going to look like this. Okay. And one thing we can do in a situation like this, with our tick marks being every 4 apart, we can go to our graphing calculator and we can go to Window. And I wasn't really looking for that. We go to negative 9.9 and 9.9 here. And we can go, our X scale we can put at 4. And our Y scale we can also put at 4. And that should give us kind of the right lineage for this big graph. So let's see what, that's the old thing, right? We got to put in this 4/3 x minus 5 plus 7, right? Let's go here. 4/3 x minus 5 plus 7, and that should get it here. Graph. And we just see the very top because we don't have the extent right and left. Let's go ahead and emulate the graph a little better. Looks like we're going up to 20 on this thing here. Let's go ahead and change that y max to 20. Should get a closer emulation here. But we're not going to the right enough. 4, 3. Let's see what we're looking like here. Yeah, that's going to be it. We're going to get the point 8, 12 should be one of them. And also 0, 12. Let's check that out. Eight, 12. Let's see. These are 4, 8. Looks like it's close. Or just, yeah, that's 8, 11. And so we can kind of see where we are in this. It's going to be 5. So you're looking for, should be, our line should be 4, 8, 12. It should be about 14 should be our y-intercept here. Yeah, that's fairly close. That's what it's going to look like. Okay, number 9. We have 3/4. Absolute value of 3/4 x minus 2. Well, our h comma k is going to be equal to, in this instance, we have 2 comma -7. So if we go to the right and down 7, these are all 2 apart. So we go down 7 here. And we're going 3/4, so that's going to be up 3, up 1, 2, 3 over 4. So we're going to be looking like this. Up 3 over 4. Something like this. That's what the thing should look like. And again, we're going by 2. So I'm going to change the aspect. We'll go from -10 to 10. And going by 2. Let's get our calculator. X scale 2. We'll go with -10 to 10. Y scale 2. And then for our y equals value here, we go 3/4. We need to delete this here. 4/3. You got 3/4, up 3 over 4, x minus 2. Okay. Three-fourths. We're going to parenthesize here. And then we have x. And I'm going to put minus. Now I'm going to put minus 2. I'm going to close parentheses. So right here, I'm going to put -7. So that should be it. Is that it? Yeah, it's going to be it. Okay, let's graph, see what this thing does here. We got 2, 7, 3, 4. We should have an x-intercept here at -2, 4, 6. Just about -8 should be our x-intercept. And yeah, that's about right. So there we have it. Okay, next order problem. 11, we have g of x equals f of quantity 7/3, quantity x plus 5, then minus 4. So in our h comma k vertex, we're going to have, this time we have plus 5, so our x coordinate for the vertex would be -5, and then our y coordinate here is going to be -4. And one other thing, we have -7/3. Well, what's going to happen to this negative sign? Well, I hope you recall that the negative sign means that whatever is negative inside the absolute value brackets turns positive. So it turns out we don't have to worry about this thing being negative. So let's go, so point here, -5, comma -4, so we go to the left 5, and we go down 4. So this is going to be our vertex. And I'm going to label that -5, comma -4. And then we're going to go up 7 over 3. So 2, 4, 6, 7, and then to the right 3. So we're going to come right through here. So our y-intercept is going to happen up here about 7. And then to the left we go up 7 over 3 this way. So we're going to be going like this. And I think we're going to be able to keep the same type of aspect for the window for the calculator as we did in problem number 9. So we're just going to change this aspect of it here, -7/3, x plus 5. Here we go. I'm going to go to the right here. I'm going to put a negative sign here. To do that, I'm going to press second INS, negative sign, 7/3. And we're going to put here x plus 5. And then the last thing, what's that going to be? That's going to be -4. Back to calculator, -4. So we'll see what it looks like here, graph. So we go 5 to the left. These are by 2, 2, 4. This is between 4 and -4, -6, and down 4. We're going up 7, 2, 4, 6, 7, and to the right 4. Boom, right there. Up 7, to the left 4. Boom, there. So that checks out. And here we have 12 and 13. Write the absolute value function in the form g of x equals. So here you're given a graph. And then from the graph, you're asked to find the equation that will match the graph. So this might require a little more advanced analysis. Here we have let b, for number 13, we have let b equal 1. So if we let b equal 1, we have to worry about a. And I hope you can see that we are opening upside down in this. Here's our vertex at 4, 3. So in the form h, k, we're going to have g of x equals. I'm going to save my a for the time being. And since b is assumed to be 1, we're going to put just x. And how far are we going to the right? Well, remember our vertex is the coordinate pair h, k. In this case, h is equal to 4. So we're going to subtract 4 here. And then we're going to add 3 on the outside. Now, what kind of a do we have here? Well, I hope you can see that we're going down. So if we go down 1 and over 1, 2, 3, 4, we should get -1/4. So we're going to get -1/4. And I'm going to erase this just to give ourselves more room. So we get -1/4 absolute value of x minus 4, close bracket, plus 3. And as always, it's helpful to check here. We got a 5, 5, 5, 5, 1, 1, 1, 1. So let's go ahead to the calculator window. We'll go -5 to 5. We're going by 1 here. Y minimum -5. Y maximum 5. And we go by 1. And then if we graph this thing up here, we should get -1/4. So I'm going to press second INS, negative. 1/4. And I'm going to erase this. And we're going to have, what do we say it was? X minus 4 plus 3. So here we are. X minus 4. And then over here on the right, we'll put plus 3. And this should get it. We should see the same thing, I hope. See, we see it right here. We got a y-intercept of 2. We got 0.4 comma 3 up here. So this checks out. So this right here is going to be our answer for problem number 13. Good luck on all these other problems. I hope this has been helpful to you. Good luck, and thanks for viewing.